Fan.
Put the fan.
Fan.
Why do you need fan?
To break the boundary
Body
layer.
layer.
Yes. So macam benda sweater semalam, mana pen aku? So ada benda senang aja dekat dalam section ni. So number one, you can control the fan speed. You have the options, okay? You can control the fan speed, but you do not care about the boundary layer conductance. Okay? But if you want your boundary layer to be of specific value, you can just press here. Okay? So now fan is on or off?
Off.
Off.
So
On.
on. So most of the time 10,000 is about the right value.
Okay.
10,000 RPM. So you see that vertical line there? Your boundary layer should falls within that.
Square.
Yeah. Although one thing you need to bear in mind, this is true for broadleaf. If you use other kind of leaf, you have to change the constant. There's other section for the constant, but since that is broadleaf, so that should be fine. So boundary layer is it within the range? Okay, so good. So good. So next,
Temperature.
temperature. Temperature ni, aduh, temperature ni. Okay, temperature. Do you want to control it or not?
No.
No. Why?
Kau semua control.
Control lah.
Oh,
Semua kena control.
Okay.
So, buat apa?
On.
Okay. So there ada quite a few terminologies kat dalam ni yang agak confusing. Okay. Most even orang kat Li-cor pun tersasut-sasut. Dia ada T exchange, T air. Lepas tu dia ada some other T's. T leaf. Ni T leaf EB. So which one yang nak patut ni? Okay, let me explain to you. T exchange referring to the temperature of the exchange plate there. The peltier device. Have I explained you about the peltier device? Yeah, that the temperature of that. T air is the current air temperature of whatever getting in. Okay.
Air.
Air, yes, this air that gets into it. T leaf is the
The leaf.
thermocouple
Oh,
temperature that is touching your leaf. Okay, so you want to set it to what temperature of the leaf or the air. So you want your leaf now to experience what temperature?
Ambient.
Berapa?
Check.
Sepatutnya plant science punya experiment, it should be 25. But we are talking about 1 ATM, you know, that one atmospheric at sea level 25 degree, that is the standard. Tapi our condition kadang-kadang tak possible nak 25 degree tu. So ambil lah yang paling mild. For rice usually people use 27 or 28. Okay. For benda ni ambil lah sama juga. Tapi remember,
Leaf ke?
no, you setkan air yang pokok tu experience.
Yelah, T apa?
T air lah.
T lah.
T air. So dah set belum T air tu? Set lah T air dah.
Kau sedap.
Currently it's 40. That's too hot.
Bakar.
Terbakar.
Habis.
Okay, simple dah.
Yeah.
Okay.
Okay.
So you can just watch it to
Tea leaf semua tak payah.
no. So
Just the air lah.
it's like this. There are three things that you can control. When you decide to control one thing, it will override the other two.
Okay.
It's the same for other sections. You have earlier on you got what? You got vapor pressure deficit, saturation deficit, and RH of air. If you choose to set RH, it will override vapor pressure deficit and the saturation deficit. If you choose to set vapor pressure deficit, it will override the RH.
Macam fan speed tadi juga.
Yeah. Like a fan speed here. If you choose to set your boundary layer with specific value, this will change. For example, set boundary layer to be 2.5. 1.8. Try to set it, and watch what happens to the fan speed.
Fan speed.
What, 2.8?
No, 1.8.
1.8.
watch what's going to happen to the fan
Fan
speed.
speed.
See, it overrides the fan speed.
So daripada 3 semua tu boleh set satu saja.
Yes.
Ni fan speed jadi 75.
Kalau kita set lagi yang lain pun dia akan tukar.
Yeah. If suddenly you change your mind, now you want to set your fan speed, it will override boundary layer punya value pula. Macam tu lah sampai sudah. Tak ada siapa boleh menang, semua dah masa satu masa sama. Okay. Seorang mesti cakap, lagi dua mesti kena dengar.
Okay. So,
Okay.
Ni tukar balik 1000.
You can use that.
Okay.
You can use that. Or you want to use the 10,000, that's a standard. If you read any literature pun dalam journal, memang gunakan standard 10,000. Because people do not want to have any headache dealing with boundary layer conductance-specific calculation. Yeah. Tapi aku degil masa TC aku main dengan benda tu banyak sangat.
10,000.
Asyik beda feel.
10,000 lah.
So,
Then okay, now go to temperature. We look at your current T air. What is the current value of your T air?
34.
Okay, it's going down. Okay. So that thing is working very, very hard. Okay. So this is quite worrying. Why your H2O is still yellow? Okay.
high-ish.
What does it say there?
High-ish.
High RH.
Tinggi yang semua bodoh.
92.
Oh, that's very high.
What happened?
That's very high. Kejap.